Okay, so our logarithm introduction. So we're just going to talk a little bit about what exactly a logarithm is. Okay, so we have two functions here. First of all, we have y equals 2 raised to the x power. Okay, so we know this is exponential function because the variable is an x. So first of all, if I raise 2 to the 0, my output is 1. If I've got 2 squared, my output is 4. If I've got 2 to the third power, my output is 8. If I've got 2 to the fourth power, my output is 16. So this is an exponential function. This is going to grow very, 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 very fast. Okay, it's going to increase really quickly. As this number increases, okay, the output's going to increase a lot. Okay, so applications of this. A lot of times we're dealing with functions that increase very, very, very fast. So rather than talk about the output, rather than talk about 16 or 8 or 4 or whatever large numbers happen up here, okay, it's a little bit easier if we flip it and only talk about the exponent. And that's what this is. A logarithm is, just, if you remember from geometry, it's just flipped over here. So what's happening, these values are flipped, okay? So what I'm going to say is y equals log base 2 of x. So the way you want to think about it is 2 to the what power is x. Okay, so for example, right, 2 to the 0th power is 1, right? 2 to the 0th power is 1. So the log base 2 of 1 is 0. And then the log base 2 of 4 is 2. And then the log base 2 of 8 is 3. And the log base 2 of 16 is 4. Really, what you're saying is 2 to the what power is my output. So we want to think about that. 2 to the what power is really what we're looking for. Okay? All right, so in general, exponential functions increase like that. Logs are flipped over the line y equals x. Right? And they're slowly going to grow. So it's a little bit easier to talk about things in terms of exponents, okay? So a couple of quick examples, and really, you just have to practice these to kind of get these around. It might take you a little bit. Okay, so first thing I wanted to look at is what happens if there's no base here. If there's nothing here, there's really a 10 here. So what you want to think about here is 10 to the what power is 10? And the answer to that question is, well, x has to equal 1. So the answer to this question is 1. So let's look at the next one. 10 to the what power is 100? 10 to the what power is 100? Okay, so if we practice our common bases, 10 to the x is equal to 10 to the second power. So this equals 2. Now, sometimes we're going to get these fractions right here. So remember, if there's no base, it's a common log. So I'm going to say 10 to the what power is 1 over 10. All right, so if I rewrite that equation, I can say 10 to the negative 1. So now I have common bases. So this is just negative 1. And I look at this last one. If it's a common log, I put it right there. And I say, well, 10 to the what power is 1 over 100. So I'm going to say 10 to the what power is 10 to the negative 2. If I just rewrite that equation or expression right there, okay, I know that this answer is going to be negative 2. Okay, so you can see our answers are exponents, right? Our answers, these are all exponents, right? 10 to the what power is 100? Well, it's the second power, right? Okay. Right, 2 to the what power is 16? Well, 4 is going to be the output. 2 to the what power is 8? Well, 3 is our answer. Okay, 2 to the what power is 4? 2 is our answer. Okay, so a couple more practice right here. We have this log base 2 of 8. So I would say, well, 2 to the what power is 8? Use your common base knowledge here. So I've got 2 to the third power. So this has to equal 3. And pretty soon you won't even have to necessarily set up your exponential equation, but it's a good habit to get into, right? So 3 to the what power is 9. So you should know that 3 to the x, I can rewrite this as 3 squared. I know that the answer is 2, right? 3 to the what power is 81. All right, so 3 to the what power is 3 to the fourth. I know that this answer is going to be equal to 4, right? And last one, 3 to the what power is 1 over 27, okay? Again, think about this as a negative exponent, so I would say 3 to the what power this is really 3 to the negative third power. Again, if bases are the same, that means my exponent here is negative 3. So again, notice our answers are exponents. 2 to the what power is 8? 3. Log base 3 of 9. 3 to the what power is 9? 2. Log base 3 of 81. 3 to the what power is 81? 4. Okay. Log base 3 of 1 over 27. 3 to the what power is 1 over 27? Negative 3. Okay. Last little 2 is what happens if I have a variable in the base, or what happens if I'm taking a log of a variable. This is where I think it's super helpful to rewrite your equation. So x to the third power is 125. Okay, so what number to the third power is 125? Our answer is 5. Now, for those of you who are algebra heavy people, we can do this. We can raise to the 1/3 and then raise to the 1/3 power. And then we can use our calculator to figure it out, because this is going to cancel out and we're just going to get x. All right. And then if we go to our calculator, I can say here, what was that? 1/25 to the 1/3 power. Okay. I can say 1/25 raised to the 1/3 power. And then our answer is going to be 5. So if you need to use your calculator, great. If not, use your tables that we can hand out to you all, okay? And again, coming up on this last example here, right? 2 to the 5th power. 2 to the 5th power is what? All right? I remember in high school, I always used to draw this. I would say 2 to the 5th. I would say x to the 3rd. Okay, you can also do that, right? 3 to the 4th is 81. 3 squared is 9, right? 2 to the 3rd, okay? So then just evaluate that in your calculator, and 2 to the 5th power is 32, okay? All right, y'all, get into your practice, okay? I hope this helps.